For this problem, again, we want to look at what kind of identity relates secant and cosecant. If you even think about the names of those are cofunctions because we have secant and cosecant. There are a couple different ways to think about this. This says that the two angles inside of these two functions have to be complementary. They have to add up to 90 degrees. Or we can also use one of the actual identities that says that secant of theta is equal to cosecant of 90 minus theta. Either way you do this one is fine. I'm going to do it by just taking the two expressions, adding them, and making my total 90 degrees. Then I'm going to solve this for theta. So I'm combining my like terms. That gives me 7 theta, and minus 18 plus 27 gives me 9. And to solve this, I want to divide both sides by 7. This problem didn't tell us how many decimal places to round to, so I'm just going to round it to 1 decimal place, which gives me 11.6 degrees. Finally, for this one, we have a right triangle, and we've got an angle measure. Be careful with these that you label the angles in the correct place. So this is angle B here. That's my 52 degrees. And I've got side A. Remember, the side letter and the angle are always across from each other. So this is A, which is 36.0 centimeters. And I'm trying to find the lengths of sides B and C. For this, since I only have the length for one side, I'm going to have to use a trig ratio to find the other two sides. If I'm going from angle B, then side B is the opposite. And the one that I do have, the A, is the adjacent. The trig ratio that involves opposite and adjacent is tangent. Tangent of 52 degrees is opposite over adjacent, which would be B over A, or B over 36. I want to solve this for B. I can cross multiply again, so I would have tangent of 52 degrees times 36. And on the other side of the equation, I would have 1 times B. For this one, I'm just going to multiply this on my calculator. And this says to round to 1 decimal place. That's going to give me 46.1 centimeters for B. I also need to find C. At this point, I could either use the Pythagorean theorem since I have a right triangle, or I could use another trig ratio. The trig ratio that would involve the hypotenuse and the adjacent would be cosine. So that would be adjacent over hypotenuse, and then I could solve this one for C by cross multiplying again. This time I end up having to divide both sides by the cosine of 52 degrees. I'm going to do that all in one step in my calculator so that I don't have to worry about rounding error. When I round that answer to 1 decimal place, it gives me 58.5 centimeters. So that's my value for C. Now we also had some problems where we were using exact values of our trig functions, and these were for specific angles. In the first quadrant, it was 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. We also had angles in the other quadrants that were special angles, and we dealt with those by finding the reference angle that was in the first quadrant. For a problem like this, if we're trying to find the exact value for the tangent of negative 510 degrees, this isn't going to be something that you can get the exact value from your calculator. What we need to do is find an angle between 0 and 360 that's coterminal with this angle, and then find the reference angle. I'm going to draw this angle, so I'm going in the negative direction, 360 degrees, and then to get to negative 510 degrees, I have to go another 150 degrees. Here's where my angle actually is. Now I want to find the angle between 0 and 360 that's coterminal with this one. So really what I'm doing is taking my negative 510 degrees and adding 360 degrees twice to get to a positive measure angle. Doing that, that gives me 210 degrees. That makes sense because this would be a third quadrant angle. And we've got in our picture, this is 180 degrees, this is past 180 degrees. So from here to here is 210 degrees. Now, since I'm trying to find the value for tangent for this angle, I need to find the reference angle. I already know this is in the third quadrant, so my reference angle is going to be the positive measure angle from the x-axis to here. That means I can take my angle and subtract 180 degrees to get the reference angle. That gives me 30 degrees for my reference angle. Now I need to figure out the tangent of 30 degrees. So for my memory trick, the sine of 30 degrees is 1/2. The cosine of 30 degrees is the square root of 3/2. That means the tangent of 30 degrees is sine over cosine. That's 1/2 divided by the square root of 3/2. I can simplify this a little bit by canceling the 2's, and that gives me 1 over the square root of 3. There's my value for the tangent of 30 degrees. I need to go back and look at the quadrant that my original angle was in to make sure I have the right sign, as in positive or negative. This is the third quadrant. If I do my memory trick for that, all students take calculus. Tangent is actually positive in that quadrant. So this would be my value for the tangent of negative 510 degrees. Another way we can use those special angle values is if we have a value and we're trying to find the angle. In this one, we're trying to find all the values of theta between 0 and 360 that would be solutions for this. In other words, we're trying to find all the angles that would have this value for the cosine. So in the first quadrant, the angle where cosine of theta is the positive square root of 2/2 is theta equals 45 degrees. Our reference angle then is 45 degrees. We want to find the two angles between 0 and 360 that have 45 degrees for a reference angle, but in a quadrant where the cosine is negative. Where cosine is negative is in quadrants 2 and 3. We want to find the angle in quadrant 2 that has this for a reference angle. To get the quadrant 2 angle, we would take 180 degrees and subtract this. That gives us 135 degrees. And then in quadrant 3, we would actually take 180 degrees and add this. So these are our two angles. And again, for something like this, it's probably going to help if you draw the picture. Here's our reference angle of 45 degrees. We're trying to find one in quadrant 2 and one in quadrant 3. So in quadrant 2, we want the angle from here to the x-axis to be the 45 degrees. So what we did here was we went all the way to 180 degrees and then we backed it up by 45 degrees. In quadrant 3, we want to have this angle be 45 degrees. So that time we were going all the way to 180 degrees and then another 45 degrees past that. So that's another way to think about getting these two angles. The next thing I want to make sure that you understand is the things that you need to be able to do with your calculator. One is to enter an angle measure in degrees, minutes, seconds format, how to convert from the DMS format to decimal degrees or vice versa, how to use the sine, cosine, and tangent keys on your calculator to find values of those three trig functions for any angle measure, and then how to use those three keys along with doing either 1/x or using the x to the negative first key to find values for the other three trig functions, and then finally using the inverse trig functions to find angle measures if you're given a specific trig function value. For these two, I've got the function values and I'm trying to go back and find the angle. That means I need to use one of the inverse trig functions. we use the inverse trig function to cancel out the function, but we have to do the same thing on both sides of the equation. For this one, if I do inverse sine on both sides, these two cancel each other out. On this side, that just gives me theta. Over here, I'm going to use my inverse sine function on my calculator. And that gives me an angle of 31.78 degrees. For this one, since it's not one of the three main trig functions, I need to use the reciprocal identity again. Secant is the same as 1 over cosine. So I could write it like this, or I could say that cosine of theta is 1 over 3.2. Now what I want to do again is I want to use my inverse cosine function on both sides so that it will cancel out the cosine. Over here I'm doing the inverse cosine of the 1 over 3.2. On this side it cancels out. This is exactly what I'm going to put into my calculator. And that gives me 71.79 degrees for theta. Here's a triangle problem. This time we have all three sides. We're trying to find the measures of the two angles A and B. So this is kind of an application problem, but it also involves using our inverse trig functions. Since we know this is a right triangle, we can look at some of our trig ratios. For example, if we look at angle A, then this is the opposite side and this is the adjacent side. So tangent of A would equal opposite over adjacent, which would be 7 over 24. If we're trying to find the measure of angle A, we could use our inverse tangent function on both sides of this. That lets these two functions cancel each other out on this side. And we can use our calculator inverse tangent function to find the measure of angle A. So for angle A, we're rounding to the nearest tenth of a degree. That would be approximately 16.3 degrees. Now, if we wanted to find angle B the same way, we could do another trig ratio to find that. But we do have a right triangle. We've got two of the angles, so we can always find the third. So to find B, we can just take 90 degrees minus our 16.3, which would give us 73.7 degrees.